All right, we're broadcasting now.
The answer that I got for 3 is 16.45.
And how did you get that?
So, you're just finding the margin of error, and the equation for that is going to be the z-score of 90%. So you plug in 0.900 in the normal probability applet, and just select the inside to get the z-score. And then you're going to do the equation of the z-score times the standard deviation divided by the square root of the sample. And that's the equation for the margin of error.
Okay.
Okay, so I'm looking at the notes, and in 3.3, the margin of error from our reading from the book, everything you just said, was that under 3.3.3?
It'll be
like your little equation you just threw out.
It's under 4.1. 4.1-ish. I say ish because we're not dealing with an actual point estimate. We're just doing the margin of error.
Here, and I think, or do I need to loop that one over just one more time? I just need to loop the bottom one over again.
Yeah.
Here it is, starting wrong spot, and then I'm ending on the spot, but then I have nowhere to twist it. Right here, but it's tied around here.
And what was the answer you got again? For number 3?
16.45.
No, I didn't get that. I think I didn't do it right.
Okay. Let me just make sure my math is right.
Try it from there.
How can I do it from there?
You're just going to hold it with your finger like that. Hold it with your finger. I don't know how it got off like that. So.
Interesting.
Okay, I got it. Did you guys get it? Number 3?
Yeah.
Okay. For number 4, would it be B?
This one's tough because the lesson doesn't actually like tell us. We basically understand that the sample mean is the population mean, or is the point estimate for the population mean, but the vice versa is also the same. And there's 2. So I think I'm missing something somewhere. I think it's B.
I agree. I think it is too, but I'm not 100% sure.
Yeah, I just can't find anything to like make me say 100% sure either, but I mean,
95% confident.
good.
Does it say how much to round? 3 decimals?
So we're number 5, right? What is the point of estimate for the true GMAT score? 526.
Yes.
Okay.
How are you guys? What? So are you finding 95% in the applet? So you're putting 0.95.
No.
And are you
Oh,
shading
yeah.
the middle and the left?
No, just the middle.
just the middle. So you got 0.6579. And then you're calculating the same thing, the 0.6579, and then we have 113 divided by the square root of 64.
Something doesn't sound right. When you typed in 0.9 into the probability applet, did you have the left and middle selected?
I did, but then you told me just the middle.
Right. And so,
But to get up to 95%, wouldn't I need the left and the middle selected? So it'd be 0.8289.
no, so you want just the middle selected and then type in 0.95 to get the z-score.
0.995, 0.95. So you're getting 1.960
No.
for your z-score. Okay, the 0.95,
Oh, yeah.
am I typing that in as the z-score or as the area?
Yeah, you're right. Sorry, I was thinking of something different. Yeah, so you should get 1.960 for the z-score of 95%.
Okay, and then from there, we're calculating 1.960. Oops, how did I do that? 1.9. And then we're doing the same calculation we did in the last one. 1.960. All right, what answer did you get for number 5? 27.685 is what I got. So I must be doing something wrong if that's not what you guys got.
No, you found the margin of error, so you found the answer to number 6.
27.685. Okay, so how do I find number 5?
So the point of estimate is going to be the mean, the sample mean.
So the answer is just 1.960.
No, that's the z-score. The sample mean is 526. So the way that I kind of got it was that the point estimate is going to be the like collected data value, I guess, or whatever the mean is. And then to find the margin of error, you're going to do the whole find the z-score thing, and then do the z-score times standard deviation divided by the sample size. So if it ever asks you for a point estimate, it's going to be the sample data.
Okay, so 5 is 526. I was overcomplicating it.
Yeah.
And 6, 27.685.
Correct.
Okay, 7. What is the lower limit of this confidence interval? Lower limit, what does that mean?
So finding the margin of error, the confidence interval, you're just going to add and subtract the margin of error from the mean data. And then the lower interval is going to be the mean data minus the margin of error. And then the higher interval is going to be the mean data plus the margin of error.
Did you get 498?
– 498.315.
Yeah, 0.3.
Yeah, that's what I got too.
I like these quizzes better because you have to do equations. And then for number 8, you have to find the upper limit.
Correct.
But this time you have to do the opposite, right?
Yeah, so add it.
Okay. I got 553.685.
Yeah, me too.
I think we lost Michelle.
Oh, we did.
Oh.
What would happen to the width of the confidence interval if Gene had increased the sample size? It would decrease.
for number 9?
Mm-hmm.
Yes.
Should we wait for Michelle?
Yeah.
Michelle.
We.
There she is.
What happened? It said I got dropped. Who dropped me? My phone just said error. You got dropped. So, okay.
That's weird.
That is weird. So we were on number 8 when I got dropped. Are we still on 8?
Or no, but we can go back to number 8.
Yeah.
Yeah, we were pretty close.
Yeah.
Upper limit of the confidence interval.
Yeah, so that one you're just going to do the population or the mean plus the margin of error.
Oh, yeah, like it, yeah. Where did you find that paper? It's me.
So you're doing 526 plus 27.685. Because we're still adding those for number 6. Okay, hold on.
Did you even see this paper?
Where did my calculator go?
Not like that. There's a lot more down there.
So 553.685.
5. Yes.
Okay, 9. What would happen to the width of the confidence interval if Gina increased the sample size? Increase, no change, decrease.
That's a white one. I need a green marker.
It would increase, the width of the confidence interval would decrease. It would become narrow. So did you put decreased?
Mm-hmm.
Okay. And 10, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
That one would increase.
Yeah.
That's increase.
Some are really brown, but
Yep.
that's not green.
Increase 11.
Some
Light bulb light company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours.
I did mine.
They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the
And the formula is in section 5 of the notes.
The one that n equals z times whatever that is over n squared.
Yeah. It's the z-score times the standard deviation divided by the margin of error squared.
If you color over it twice, then it will make
Z
it
times standard deviation is 400 over, okay, what is m? 50? Is
Yes.
m margin of error? So we have 50. So the z-score we need to find is 95%. So when I'm plugging that into the applet, sometimes I mix these up. We're putting that in as the z-score. Am I shading the left and the middle?
No, so
Only
when you're
the middle?
finding the confidence value, it's only going to be the middle, correct?
Because it's confusing to me because I feel like 95% would be everything up until 95%, not just the middle.
Right. So the thing is we're not finding the probability. We're finding what's the way to word this? We're finding if the mean value is within 2 standard deviations away from the population mean. And so if we follow the 68%, 95%, and the 98% or 99%
How did you make the hole?
rule of the standard deviations and stuff like that, the 95% comes from being within 2 standard deviations. And so what we're just trying to find the number that's within that width, basically. And then as you progress, you can then change that that percentage value, so you don't have to stick to the 1 deviation or the 2 deviations. You can do like a 90% or a 99%. Find that confidence value.
All right, did you guys get 28? Because the answer I got was 27.701, but it says round to the nearest whole number. Okay, so here's the number I calculated. If nobody else got that, I got the so from the applet when I typed in 0.95 on the z-score, then the one up there gave me 0.6579. Did I do that wrong?
You want to switch that.
Switch that. So up top, I'm putting 0.95. So the number would be 1.960.
Yes.
Yeah.
1.960. Okay.
And it
Went
also,
wrong there.
in 4.1, it says most commonly used values for Z are, and it has the 90, 95, and 99%. So you don't have to plug it in the applet.
Yeah. After a while, like the 90% is like the 1.645, 95 is 1.96, and the 99% is going to be like 2.576.
Yeah.
Yeah.
So you guys got 246.
Yes.
Mm-hmm.
Okay.
But I thought the answer for number 11 was 1.96. No, 1.960.
No, that's the z-score.
Yeah. Then you have to calculate it into the
Applet. Okay.
the 1.960 times 400 divided by 50 parentheses
Squared.
squared.
Yeah.
That was the formula I
So
had
246.
from sample size calculations 5 in the homework or the reading. Okay. What is the lower limit of the 95% confidence interval? Lower limit.
My eyes are kind of black.
Is there a certain calculation just for the lower limit?
You subtract, right?
Oh, there we go. Here's what it's supposed to
For
Yeah,
the
so-
lower, yeah.
I can't make a pumpkin. Look. I did you right.
Okay, so you're subtracting the 111,000, take away 110,000. So then you have 11,000. And then is this the one where we do, is that one from our last lesson? Divided by something square root 36.
To make a third pumpkin. These pumpkins are
So.
Or am I in left field? What are you guys calculating? I guess we'll start there.
So the first thing you're going to want to do is you're going to want to use the sample information, not the standard information that it gives you. And so to find the margin of error, you can do that. It's going to be the 1.96.
Okay, from the applet, got that.
Yeah, the 1.96 times the deviation, which is 36,730.
And this time I do not need to cut it.
And you divide by the sample, which is 36. And that'll give you the margin of error, which
7.4. 7.4.
oh, did I mess up on my calculations? Oops.
No. Yeah, one. Sorry, I'm talking to myself.
So 1.96 times 36730 divided by 36.
Right.
And I got 1,999.74 cents.
Wow, that's a long number.
Wait, did you divide by the square root of 36?
Square root, nope, sure didn't. There we go. So now I got 11,998.
0.467, right?
So
That's
we
what I
got
got.
11,998.466 is all that my calculator showed me.
Rounded to the nearest whole number.
So we'll just do 0.47.
No, so after you get that margin of error, then you got to do the 111,000 minus that number, and that'll be the lower limit. Alrighty. Were you able to figure out 12 and 13?
Almost. I'm just writing it all down so that I can plug it into the calculator.
Gotcha.
So we have the x minus 1.96, and then the little standard deviation divided by the square root of n. That was a calculation you did, right?
Yes.
Mm-hmm.
Okay, so square root of n would be 36. This really should not be taking this long to try to calculate this. 3673 divided by the square root of 36. Okay, so did you guys get 99,001.53?
Yes. Yes, and then you're going to want to round up.
So 99,001.53. Or are you rounding up to
So that
99,2?
Yes.
Oh,
99,002. Did I do it? Oh my gosh, I think I did it. About freaking time. Okay. Oh no. What is the upper limit of this 95?
It
so
wouldn't
the
be
only thing, same thing, just a plus.
yeah.
Yes.
So instead of a subtract, we're going to add there. What kind of calculators do you guys have?
I have a TI 30X.
I have a TI 86.
Fancy.
I have 84.
Oh, talk nice, girls. You are nice girls. So then you say, Emma, would you like to play Barbies with me?
She said, I know what to do.
Okay, so go play. Play nice together.
All right, and then so what do you guys get for 13?
122998.
Cool, me too.
12298. Okay, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample was drawn from the population. Okay, standard deviation is known. X is normally distributed. All of the above.
It's in 4.4 in the notes.
Yep. Easy. Alrighty.
So we have
I
all of
have
the
to go.
above.
Pretty actually kind of right now.
All of them? Oh, sorry, yeah.
When do we want to meet again?
I can meet Wednesday, but I work at 6.
Okay, I can do Wednesday. I just have to get kids from school at 3:40. So then by the time I'm home, I'm usually on by like 4.
So Wednesday at 4?
Wednesday at 4 works for me.
Wednesday
Yes.
at 4 sounds good. Awesome.
Alrighty. Bye, everybody.
Bye. Thanks for your help.
Bye.
What